So this is going to be one of many videos this series, and I'm just going to record my progress on designing, programming, and everything with this V2X robot that I'm going to design for a competition, and it's hosted by Square One, and start by reading the important parameters. So over here we have the budget that we have per vehicle, and it's only $400. Over here is our build dimensions that we cannot exceed. So it can't be bigger than 12 inches in length, 12 inches in width, and 8 inches in height. And then we also had to make an infographic or poster. And then for the first task, it's due in video format on February 4th, and that's like 2 weeks from now. Then the second task is like a week after that, and then the Charlie task. And these are the different tasks, starting with the alpha task, where we gotta record our vehicle, just drive around pretty much, 12 inches right, forward, backwards, left, spin, and then it has to indicate when it's completed its course and challenge, either with light, sound, or any other thing. And it has to be done under a minute. So this is usually like the first and easiest task. Then the second task, it just needs to be able to sense objects in front of it, and it has to travel 24 inches forward, and then once it's starting to get close, it has to indicate that it's starting to get close to an object, and then permanently stop at 6 inches from the wall or any obstruction using lights or sound. And then it has to be done under a minute, and that's also submitted with a video. And then the Charlie task is where you have to place 2 round obstacles such as soda cans, glue sticks, etc., 24 inches away from each other, and then we gotta show that it's the exact distance so that the judges see when you send the video in, and then it has to make as many figure eights around the 2 soda cans or glue sticks in 45 seconds, and gotta report how many laps are made in the video. And those are the only 3 videos that are submitted through video. And then the rest of the tasks are in person, 4 through 7, I'm pretty sure. Yeah, 4 through 7 are all in person. So I'm just gonna explain the 4 through 7 tasks when we get there and actually start working on it and programming it. So this is the progress that I've done on it. I've done all the CAD or computer-aided design, whatever you call it. So I've done this all in Onshape, and let's see. For my V2X robot, I'm gonna do swerve, which that is there's 2 motors. I'm gonna use the servo motor to control the rotation of the wheel, and then this motor is gonna control the drive. So right here you can see that it's spinning only the wheel. And then over here, it's gonna be for the servo controlling the turn on that, and I started building so this part is gonna be made out of acrylic, laser cut acrylic, and most of the other parts is gonna be 3D printed, but then I'm still gonna have bearings. So this is the entire chassis with all 4 swerve modules, and the gears and all the other parts are going to be 3D printed. This part, I'm just going to use metal extrusion. And then this part, the belly pen, is going to be laser cut, also made out of acrylic. And then I'll probably have the 3D files on my Printables account. I've only got like three things on there so far, if you want to check that out. So these are the only things that I've got. Got a candy cane pen, succulent pot for my succulent, so do nicely. And then a phone case for my phone. No? So, yeah, I'm not doing that good, but hopefully you guys can change that if you're watching this. It's just Gomez LZ. If you want to check that out for any of these. So yeah, most of it is going to be 3D printed. All the blue parts is going to be 3D printed in PLA. And the green is going to be printed in TPU. Then I'm going to have a bunch of bearings, and then I'm going to have metal shafts, metal hex shafts that I got from, because we also do FRC, so I'm just taking the metal extrusion and the bearings from the FRC. Hopefully it's under $400, hopefully. Also, there's no weight limit, but there probably is going to be after I'm finished, because right now, from what I built, so let me show you what I built. So I only built 2 of the modules, not fully this one, but I finished this one, and I got here, pretty much got only that part of it done. I still had to finish this part, but just that, right now it only weighs like 7 pounds, and like I'll show you last year's V2X robot that I designed. Right now I'm only just using him for display, but so this was the robot that I designed last year. There's our robotics logo. REST Robotics stands for Roseville Engineering Science Technology Robotics. It's REST Robotics Club. And then that's the one motor. And then it looks very messy, very poorly made. But this was my first year designing a robot fully, because all the other years I just used a already commercially available robot. But this year I fully designed it, made it so that it's got this type of steering, whatever it's called, like regular car steering, and it's all powered with the Arduino. Here's the accelerometer MPU, and here's the Husky lens camera, which is an AI camera, and ultrasonic sensor. So this is the robot so far, and everything that I've been working on it. It's like not even fully built. Just one part of it. This is the biggest chunk and part of it that I finished. No, we got the first motor and then the servo. And over here I only got the motor on there. And I'm gonna have all the electronics and everything on here. Like instead of using an Arduino Uno, I'm gonna use this Arduino Mega from Key Studio, not from Arduino, but it's fine. And then I'm also 3D printing the belts, which is made out of TPU so that it's nice and squishy. And then the wheels, the wheels are also TPU so that they have extra grip on the floor. And it's the rest of the stuff that I'm going to be using on that. The middle shaft spins on all four corners. And this is the battery that I'm going to use. It's probably going to be like right over here, powering everything. And it's an RC car, a remote controlled car battery. So it's got a lot of voltage and amperage. And yeah, that's pretty much it. So probably gonna have the microcontroller somewhere around there, maybe more like that, so that these motor controllers can go in the front and the back for the 2 pairs of motors. These motors, because these servo motors don't need any motor controller. It's already built in, so. And the motor controllers can only control 2 motors at a time. So those 2 motors and then these 2 motors are gonna be controlled separately with those. And then I'm also gonna find a way to attach. This is an encoder, and it's gonna be mounted somewhere over here with something so that it can sense how many revolutions per second, per minute, whatever, so that it can drive in good speed. All 4 corners aren't finished yet because my 3D printer. I have the Ender 3S1, and so the thermistor on it right over here, thermistor. So what happened was it pretty much broke, so I tried changing it with a different one, and since it had like different resistance readings, it's reading here. Let me show you. Turn it on. So it thinks it's at 83 degrees when in reality it's like 23 degrees. So either I have to go in and change the firmware, or I change the thermistor to the right one. So I've been trying to change the firmware, but I don't know how to send the code to it, all the firmware to it. I'm trying to use VS Code, or what is it called? VS Code, and so because I've changed the code, the firmware. I just need to upload it to my 3D printer. But yeah, so after I figure that out, I'm gonna finish printing the rest of the pieces. Then I should be done. Maybe, hopefully, I finish building the entire vehicle by next week, and then program it to do the first task. Because it shouldn't be that hard, but hopefully I get it done on time. February 4th or something. But yeah. Also, one thing I forgot to mention was the dimensions that I have for in the CAD, and what I'm going to do in the design is the max 12 inches by 12 inches. And right now the height from this top part is like 6 inches, so still got 2 more inches to go from the height. But yeah, the length and width is the max that it can be. So as you can see, I have most of the parts printed now, but it's not all of them. I'm missing 4 hard plastic pieces that I still need to print, and 4 TPU parts that I still need to print. I need to print 2 belts in TPU and 2 tires in TPU. And then, so I didn't end up getting my printer to work. I changed the firmware. I found out how to do it, and I was able to send the code, but every time I sent the firmware to it, the bed, like while the firmware is changing and updating inside the 3D printer, the 3D printing bed, like the bed of it, just started heating up and overheating, and then the firmware was like, it was still in like the loading screen while the firmware is being updated, and the bed was like overheating. So I changed back to the old firmware, what it used to be. So I'm just gonna buy a new thermistor, like the actual thermistor that I'm supposed to get, instead of just a random thermistor I just found laying around. So, but I'm not gonna get that until next week, like Saturday of next week. And right now the date is today's January 31st, and the task is due February 4th, and that's next week Tuesday. Yeah, next week Tuesday. No, wait, no, shoot. Is it, or maybe it's Wednesday. No, it is Tuesday. Okay, so it's next week Tuesday. And so I didn't have time to print the parts on my printer, so I used someone else's printer, and they have a Bamboo Lab A1, and they printed all these parts really fast, in like less than 2 days. And so yeah, I'm just gonna start building it. I just need 4 more hard plastic pieces, and then 4 more TPU pieces. This project uses a lot of bearings. It's like 5 bearings per swerve module. So, okay. I was looking for the shafts. I've got it. Oops. Yeah. That was my bad. Okay. There we go. Shafts. So, let's see. I still need to attach the TPU tire on here, this part, for the grip on the floor. So right now it's very slippery. So I am Sigma. So tolerances on this part is a little too loose. So what I'm going to do is solder these two pieces together. Oh snap, I found it. I got my soldering iron. Damn. So, it's plugged in right now. I'm waiting for it to heat up. Okay, there we go. It's in focus. Oh, it's not hot enough yet. Wait for that to heat up a little more. Oh shoot. Not even a frame. Oh snap.
I am Sigma.
Leave that there for now. So, okay, that part goes right over here. Comes out easily, but this part is gonna help it keep it in place. Hopefully. For this part, you need to take the bearing off. Take the bearing off and first place it on here. And then you place it on. Yeah. Now it doesn't come off. A little loose, but that makes the gears mesh more smoothly. Hopefully. Yeah. One of the parts that I still need to print is a spacer that goes over here. It's one of the parts. And another one is a servo shaft that goes over here. Okay, that works beautifully. There we go. Yeah, this shaft goes over here so that this doesn't slide around too much, but right. Okay, that works beautifully. The thing skips gears. So I gotta fix that. So extend out a little more. So okay, so I'm just gonna extend this out a little bit. Okay. Nice little. And what I'm doing is adding a ridge over here so that it doesn't go in all the way. So let's see if that works. Yeah, it does. Okay, perfect. That's usually what I do. I just use my soldering iron instead of having to reprint the entire thing. Let's see if it works. And then if I... Oh yeah, that's not skipping gears anymore. Okay, there we go. I'm just gonna place this here to act as a what is it called? As a spacer. It's not actually going to be there. Oh, it's not aligned at all. There we go. Let's see. Well, it only skips when it's all the way back. But if it's down, yeah, it doesn't skip when it's, but when it's flat on the thing, it skips gears. But since gravity is going to be pushing it down, it works perfectly.
I am Sigma.
This is what I have built so far, pretty much all four corners. I just need to finish the back too with the rest of these pieces, but I haven't finished printing all the pieces. I still need 4 pieces, and then 4 like PLA pieces, and then 4 CPU pieces. And after that, I'll finish it, move on to programming, and finish it. I mean, I've already done some of the programming. And the task, so the rest of the parts are going to be finished printing tomorrow. So I'll have to get those pieces. And then I'll probably finish building it that day, tomorrow, which will be February 1st. And since the task is due February 4th, I'll probably have the task done by February 2nd. And then probably record it on February 2nd. And then February 3rd, I'll edit the video and send it one day early before it's due. But yeah, and also I've done some of the calculations on how much it costs right now. And like the budget is 400, and right now all of this costs about like $250, $280. So we still got like $150 left, which is still quite a bit, which I'll probably just use that on sensors. And yeah.